So that looks pretty blue, so it might be soapy water, but it's blue, which means we've got water, soapy water in there. Okay, but let's see what would happen if instead we had a very vinegary mix. Okay, we think it might explode. Okay, I like that theory, but we might be getting ahead of ourselves. Let's just watch what happens. Okay, so what's happening here? Okay, it changed color, and that is because we now have vinegar instead of water. And so our bromothymol blue is telling us that we don't have water in here, we have something else that's like vinegar. Okay, awesome. Now, I hear some of us are saying explosion. Do we want to see an explosion? Okay, so I have just the thing to make that happen, at least a little kind of explosion. This is baking soda, and I guess we know what happens when we mix baking soda and vinegar, right? Especially if we do a volcano activity with it before, yeah. So, let's take a look. We're probably going to see two things. First of all, volcanic eruption. Secondly, what do we think might happen to our color here? It might change color again, right? So let's put a giant scoopula full of baking soda and see what happens. Sounds good? 3, 2, 1, and whoa! We've got a really fast, bubbly reaction. I'm gonna put a little bit more in there. Okay. And then a fun thing that I'm gonna do now that I put more baking soda in there, I'm gonna roll up my sleeves, and I'm gonna stir it around in here. What color do we see now? Blue! Okay, so now we don't even have an acidic solution here anymore. The vinegariness is all gone because we mixed it with the baking soda. And we've got that carbon dioxide here. Okay, pour more vinegar in. I think we want more explosions. So, if I tell you that my next demonstration is elephant's toothpaste, would that be exciting for you? Okay. It's going to be a very similar thing, a little bit on a bigger scale. So I think that'll be exciting for us. So with that one, we got to see a couple more clues that a chemical reaction might be happening. So we've got those bubbles, which means that a gas was created by our reaction. And secondly, we've got color change, which is a really good indicator that we've got something chemical going on. Okay, elephant's toothpaste. So first of all, I'm going to be a good example, and I'm going to be very safe when I do this. So I'm going to tie my hair up so you can not get elephant's toothpaste in my hair. I'm going to put on some goggles, which you should always be wearing if you're dealing with chemicals. And I'm going to be wearing gloves to protect my hands from harsh chemicals that I'm going to be using. So, first of all, to make elephant's toothpaste, our first ingredient is hydrogen peroxide. Who here has heard of this chemical before? Okay, hydrogen peroxide. A few of us. Okay, hydrogen peroxide can be used to disinfect wounds in lower concentrations than this. This is a 30%, so it's a little bit of a higher concentration, which is why I have to wear gloves when I handle it. So let me just put 20 milliliters of that in here. I'm very focused. And put 20 milliliters, perfect. Okay, let me just close that. Okay, that was the only really harsh chemical that I have to use, so I'm going to take my gloves off now. And next up, my next ingredient is Dawn dish soap. Exactly. Who here has used dish soap before? Excellent. So maybe you all help to wash dishes at home, or maybe you just like to make a mess of bubbles in the sink. Either way, you know what Dawn dish soap is, or dish soap in general. We're just going to put a bit of dish soap in there. So now we've got a couple of ingredients there. Okay. Next up, we have two options for a color, and so I need people to vote for what color we want. So, I've got yellow or green. So raise your hand if you want green. Raise your hand if you want yellow. Give yellow a fighting chance. Okay, I think green? Yeah, okay, we seem pretty happy with that. So let's do green. Definitely a good sciencey kind of color. Okay, I'm gonna put a lot of good green in there. And swirl those around. Awesome. Okay. And now, our last ingredient is potassium iodide. And we need this ingredient because if you take a look here, do you see very much happening? Not really. No, we've got like a couple bubbles on the surface. But believe it or not, there's actually a reaction happening right now. It's just happening really, really slowly. So we need something to speed it up. And we have a term for this kind of ingredient in chemistry. It's called a catalyst. So a catalyst is going to kickstart the reaction, and our catalyst is potassium iodide. So let me just put a nice scoop of potassium iodide in here. And that was kind of goofy and gross, but now it looks a lot cooler. Yay! Okay, very tempting to touch this, but I wouldn't recommend that. So, what do we notice happen here that can tell us that it's a chemical reaction? Bubble reaction, explosion. Okay, I really like that.